I'll leave the derivation of the logarithm rules and exponent rules, derivative, antiderivative, etc., to you to read in the text, but suffice it to say, in Chapter 6 we have learned the following new facts. First of all, the antiderivative of x to the n dx we know is x to the n plus 1 over n plus 1 plus a constant when n is not equal to negative 1. And then by definition we have come up with that the antiderivative of 1 over x, that is x to the negative 1 dx, is the natural log of the absolute value of x plus a constant. This gives us also a new differentiation law, and that is, of course, that the derivative with respect to x of the natural log of x is 1 over x. Added to our original formulas, we now have the powers rule complete. So let's see how we can use this. For example, let's take the antiderivative of x squared over x cubed plus 5 dx. Previously, we could not let u equal the entire denominator of a function because we wouldn't have known what to do with the 1 over u when we're there, but now we can. Let's say u equals x cubed plus 5. Then du dx is 3x squared, and du over 3 is x squared dx. There's our x squared dx, so we have 1 over 3 times the antiderivative of 1 over u du. That's 1 over 3 times the natural log of the absolute value of u plus a constant. That's 1 over 3 times the natural log of the absolute value of x to the third plus 5 plus a constant. Similarly, we could look for the derivative with respect to x of the natural log of x cubed plus 5. That's going to be, using the chain rule, the derivative of the natural log function evaluated at x cubed plus 5. So 1 over x cubed plus 5 times the derivative of x cubed plus 5. And that gives us 3x squared over x to the third plus 5, which shouldn't be much of a surprise comparing that to what we have up on top. We also have invented, as it were, a number, e, which is an important number for many different reasons, but one reason is because using base e, the derivative with respect to x of e to the x is in fact just e to the x, which implies that the antiderivative of e to the x dx is e to the x plus a constant. Remember that e is a number. It is not a letter or a variable or anything. It's like pi. In fact, it's a transcendental number. It's 2.71828, and it wanders off from there, a little more than 2.7. E and log are related by the fact that the natural log of x is in fact the log to the base e of x, which means that the natural log of e to the x, they are inverse functions, is x, and e to the natural log of x is x. So we have these new facts that we can use in our homework. Let's take a couple examples here. First of all, how would we do something like the antiderivative of e to the 3x plus 5 dx? There are two ways to do this. One, we could use properties of logarithms and call this or exponents and call this e to the 3x times e to the 5 and pull the e to the 5th out. Most people would simply let u be the 3x plus 5, then du dx is 3, and du over 3 is dx. This gives us then 1/3 the integral of e to the u du, which is 1/3 e to the u plus a constant, which is 1/3 e to the 3x plus 5 plus a constant. Also, now we know how to do derivatives of exponential functions. And when we're doing those, let's take a look at something. Let's compare something. First of all, remember the derivative of a variable to a constant power, we use the powers rule. On the other hand, the derivative of e to the x is not x e to the x minus 1, because this is now an exponential function, not a polynomial function. X is our variable. Very, very different situation. And we know that's just plain old e to the x. How do we handle other bases? Well, we use the change of base formula. Notice that 3 to the x is the same as e to the natural log of 3 to the x. Simply inverse operations. Properties of logarithms say that this is equal to e to the x times the natural log of 3. Therefore, what's the derivative of 3 to the x? That's the derivative of e to the x times the natural log of 3. And then using the chain rule, that's e to the x times the natural log of 3 times the derivative of x times the natural log of 3. Well, natural log of 3 is just a constant, so the derivative of x times the natural log of 3 is the natural log of 3. E to the x log 3 is 3 to the x. So this is actually 3 to the x times the natural log of 3. If you want another formula to memorize, you can remember that the derivative of anything to the x is anything to the x times the natural log of anything. Similarly, the antiderivative, using this same substitution, the antiderivative of anything to the x with respect to x is anything to the x divided by the natural log of anything plus a constant. Let's stop there, and we'll take some examples in a minute.